Preparing for a technical interviews at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a highly available hybrid cloud application for an enterprise client? I would begin by classifying workloads, data sensitivity, recovery objectives, and latency requirements. Critical services would run across multiple availability zones, with load balancing, automated health checks, and replicated databases. A secure VPN or dedicated connection would link on-premises systems to cloud resources. Infrastructure as code would make environments repeatable, while centralized logging and monitoring would support operations. I would test failover regularly and document ownership, runbooks, and recovery procedures. The design should optimize resilience without over-engineering low-risk components. While answering, cover requirements gathering, workload placement, redundancy across zones, connectivity, identity, disaster recovery, monitoring, data synchronization, security controls, and the trade-offs between cost, latency, operational complexity, and vendor lock-in. Question 2. What is the difference between incident, problem, and change management in ITIL? An incident is an unplanned interruption that requires rapid restoration of service. Problem management investigates recurring incidents and removes their root causes. Change management controls modifications so they are assessed, approved, tested, scheduled, and reversible. For example, a failed database restart is an incident. Repeated failures become a problem. Upgrading the database engine is a change. I would track relationships among records, communicate impact clearly, and use metrics such as resolution time, recurrence, and change failure rate to improve service quality. Make sure to cover the purpose of each practice, urgency versus root cause analysis, change authorization, service impact, documentation, communication, post-incident review, and how the practices work together in managed services operations. Question 3. How would you troubleshoot a production server that suddenly shows high CPU utilization? First, I would confirm whether one host or a broader service is affected and check recent deployments, traffic changes, and alerts. I would inspect process-level CPU, memory pressure, disk I/O, thread counts, and application logs, comparing them with a normal baseline. If customer impact is serious, I would scale capacity or fail over while preserving evidence. Then I would isolate the cause, such as a runaway query or loop, apply a tested fix, verify performance, and create a follow-up problem record. In your answer, talk about confirming scope and timing, checking processes and dependencies, comparing baselines, examining logs and metrics, mitigating safely, identifying root cause, validating recovery, and preventing recurrence. Question 4. What networking concepts are essential when supporting enterprise infrastructure? I consider addressing, routing, name resolution, segmentation, and security the foundation. DNS maps service names to addresses, routing moves packets between networks, VLANs separate traffic, and firewalls enforce policy. For troubleshooting, I verify the physical or virtual interface, IP configuration, gateway, DNS response, route path, and port availability using tools such as ping, traceroute, dig, and curl. I also distinguish latency from packet loss and application errors. Clear diagrams and documented dependencies make enterprise support faster and safer. Be sure to mention TCP, IP, DNS, DHCP, routing, switching, VLANs, firewalls, load balancers, VPNs, subnetting, latency, packet loss, and practical diagnostic tools such as ping, traceroute, NSLookup, and packet capture. Question 5. How would you automate repetitive infrastructure tasks safely? I would first define the desired state and identify inputs, dependencies, permissions, and rollback requirements. I would store Terraform, Ansible or script code in version control, review changes through pull requests, and keep secrets in a vault rather than source files. Idempotent operations allow repeated execution without unintended changes. I would test in a non-production environment, use plan or dry run output, deploy gradually, and capture logs. Automation should reduce human error while preserving approvals, audit trails, and an emergency recovery path. While answering, focus on infrastructure as code, idempotency, version control, peer review, parameterization, secrets management, testing, staged rollout, rollback, auditability, and selecting tools such as Ansible, Terraform, or scripting languages. Question 6. How would you secure a hybrid environment containing legacy systems and modern cloud services? I would inventory assets, data flows, identities, and business criticality before selecting controls. Cloud and legacy systems should use centralized identity, least privilege, multi-factor authentication, network segmentation, encryption, and monitored administrative access. Where a legacy platform cannot be patched, I would isolate it, restrict protocols, add compensating controls, and define a replacement plan. Logs should feed a security platform with actionable alerts. I would regularly test vulnerabilities, backups, and incident response, balancing risk reduction with operational continuity. In your answer, cover asset inventory, identity-centric access, least privilege, segmentation, encryption, patching constraints, compensating controls, vulnerability management, centralized logging, threat detection, compliance, and a phased modernization strategy. Question 7. What is your approach to designing a disaster recovery strategy? I start with a business impact analysis to establish recovery time and recovery point objectives for each service. Then I map application, network, identity, and data dependencies and choose appropriate backups, replication, or alternate sites. High availability handles local failures. Disaster recovery addresses larger disruptions, so they are not interchangeable. I would automate recovery where practical, document runbooks and responsibilities, test restoration and failover regularly, measure results against objectives, and update the plan after architecture or business changes. Make sure to cover business impact analysis, RTO, RPO, dependency mapping, backup types, replication, recovery tiers, geographic separation, runbooks, testing, ownership, and the difference between backup, high availability, and disaster recovery. Question 8. How would you migrate a traditional data center workload to the cloud? I would discover the workload, dependencies, utilization, licensing, data classification, and recovery requirements. Based on those findings, I might rehost quickly, replatform for managed services, or refactor when long-term value justifies the effort. Before migration, I would establish a governed landing zone, connectivity, identity, monitoring, backup, and cost controls. I would rehearse data movement, test performance and security, use a controlled cutover with rollback, and optimize resources after observing real usage rather than relying on estimates. Be sure to mention discovery, dependency assessment, business requirements, migration patterns, landing zones, security, network connectivity, data transfer, testing, cutover planning, rollback, cost control, and post-migration optimization. Question 9. How do containers differ from virtual machines, and when would you choose each? Virtual machines emulate complete operating systems on a hypervisor, while containers share the host kernel and package applications with their dependencies. Containers start faster and use fewer resources, making them effective for microservices and repeatable deployments. VMs provide stronger isolation and support different operating systems or legacy workloads. I would use containers with image scanning, resource limits, and orchestration controls, but choose VMs for kernel-specific software, sensitive isolation requirements, or applications not yet suited to containerization. While answering, compare isolation, kernel sharing, startup time, resource overhead, portability, security boundaries, orchestration, workload compatibility, stateful applications, and situations where virtual machines remain the safer choice. Question 10. What monitoring and observability strategy would you implement for a managed enterprise service? I would combine metrics, logs, traces, infrastructure events, and synthetic transactions to understand both system health and user experience. Each service needs defined service level indicators, such as availability, latency, and error rate, with thresholds based on meaningful baselines. Alerts should be actionable, deduplicated, routed to the responsible team, and linked to runbooks. Correlating telemetry across dependencies accelerates diagnosis. I would review alert noise, dashboard usefulness, retention, and service level objectives regularly, ensuring monitoring supports business outcomes rather than collecting data indiscriminately. In your answer, talk about metrics, logs, traces, service level indicators, alert thresholds, dashboards, correlation, synthetic checks, noise reduction, escalation, retention, access controls, and linking technical signals to business impact. Question 11. How would you respond to a ransomware incident affecting critical servers? I would declare a security incident, activate the response plan, and isolate affected systems without destroying evidence. The team would disable compromised accounts, block known indicators, preserve logs and images, and determine scope. I would involve security, infrastructure, legal, communications, and business owners, following notification requirements. Recovery would use verified offline backups, clean images, prioritized dependencies, and heightened monitoring. After restoration, I would investigate the entry point, close control gaps, rotate credentials, test defenses, and document lessons learned. Make sure to cover incident declaration, containment, isolation, evidence preservation, communication, identity control, backup validation, eradication, recovery sequencing, legal obligations, lessons learned, and avoiding actions that destroy forensic evidence. Question 12. How do you troubleshoot a database query that has become significantly slower? I would compare current execution time with a known baseline and inspect the query plan for scans, inefficient joins, cardinality errors, or missing indexes. I would also check statistics freshness, blocking locks, CPU, memory, storage latency, data growth, and recent application or schema changes. I would reproduce safely, test an index or rewritten query in a controlled environment, and measure both improvement and write overhead. Any production change would be reviewed, scheduled, monitored, and reversible, especially on a critical managed service. Be sure to mention query plans, indexes, statistics, locking, data growth, resource saturation, recent changes, parameter behavior, replication impact, safe remediation, and measuring improvement against a baseline. Question 13. Explain Zero Trust architecture and how you would apply it to enterprise operations. Zero Trust assumes no user, device, or network location is inherently trusted. I would enforce strong identity, multi-factor authentication, least privilege, device posture checks, short-lived access, and explicit authorization for every sensitive resource. Administrative access would use privileged access management with approvals and session logging. Microsegmentation would limit lateral movement, while encryption and centralized telemetry support detection. I would implement it incrementally, starting with high-risk identities and assets, then measure reduced exposure without disrupting legitimate business workflows. While answering, cover continuous verification, least privilege, strong identity, device and workload posture, microsegmentation, policy enforcement, encryption, telemetry, privileged access management, and gradual implementation around business-critical systems. Question 14. How would you design a scalable API for an enterprise integration platform? I would define stable resources and contracts first, using consistent status codes, validation, pagination, and versioning. Authentication might use OAuth, while authorization would enforce tenant and role boundaries. Idempotency keys would protect retrievable rights, and rate limits would prevent abuse. Timeouts, bounded retries with backoff, circuit breakers, and queues would isolate dependency failures. I would publish an OpenAPI specification, add contract and load tests, instrument latency and errors, and preserve backward compatibility through a clear deprecation policy. In your answer, discuss resource modeling, authentication, authorization, versioning, idempotency, pagination, rate limiting, validation, retries, timeouts, observability, backward compatibility, and resilience against dependent service failures. Question 15. What makes a reliable backup strategy, and how would you verify it? A reliable strategy starts with workload-specific RPO and RTO requirements, not simply a backup schedule. I would maintain multiple copies across different media or locations, including immutable or offline protection, and encrypt them with controlled key access. Application-consistent backups are essential for databases and transactional systems. I would monitor job success, capacity, and unusual deletion activity, then perform scheduled restoration and full recovery tests. The evidence should demonstrate that data is usable and services return within agreed objectives. Make sure to cover recovery objectives, the 3-2-1 principle, immutability, encryption, retention, application consistency, access controls, restoration testing, monitoring, backup failure alerts, and evidence that recovery meets business requirements. Question 16. How would you manage a critical change with a tight maintenance window? I would clarify the business objective, affected configuration items, dependencies, risk, and success criteria. The change record would include tested implementation steps, timing, owners, validation checks, and a practical rollback plan. I would obtain appropriate approval, notify stakeholders, confirm backups and access, and assign technical and communication roles. During the window, I would use checkpoints and monitor customer-facing indicators. If validation fails, I would execute the backout plan quickly. Afterwards, I would document results and review any deviations. In your answer, cover impact assessment, approvals, implementation and backout plans, testing, stakeholder communication, staffing, monitoring, decision checkpoints, change freeze considerations, and post-implementation validation. Question 17. How would you diagnose intermittent connectivity between an on-premises network and cloud resources? I would correlate failures by source, destination, protocol, time, and application, then compare successful and failed flows. I would check tunnel or dedicated link status, routing tables, security rules, DNS responses, NAT behavior, MTU, packet loss, and asymmetric paths. Cloud and network provider metrics can reveal resets or capacity limits, while packet captures help confirm where traffic stops. I would apply the least disruptive mitigation, such as rerouting or adjusting a validated rule, then monitor recurrence and document the root cause. Be sure to mention problem scope, timestamps, route and tunnel health, DNS, security rules, MTU, packet loss, asymmetric routing, provider metrics, packet captures, correlation, and separating network symptoms from application behavior. Question 18. What is your approach to capacity planning for infrastructure supporting a growing client workload? I would collect historical demand, utilization, latency, queue depth, storage growth, and business forecasts, then identify the resource that saturates first. Capacity models should include seasonality, growth scenarios, failure of one component, and required headroom. I would define scaling thresholds and lead times for procurement or cloud reservations, comparing capital and operating costs. Forecasts must be reviewed against actual behavior, because architecture changes can invalidate assumptions. I would prioritize customer-facing performance and resilience over maximizing average utilization. While answering, focus on demand forecasting, baselines, utilization trends, saturation indicators, performance objectives, seasonality, scaling thresholds, headroom, cost modeling, failure scenarios, and validating forecasts through regular reviews. Question 19. How would you use DevOps practices to improve reliability in an enterprise environment? I would standardize work in version control and automate builds, tests, security checks, infrastructure provisioning, and deployments. Small changes are easier to review and roll back than large releases. For production, I might use blue-green, canary, or phased deployment with automated health checks and clear abort thresholds. Infrastructure as code improves consistency, while observability verifies customer impact. Enterprise controls still matter, so approvals, audit trails, segregation of duties, and emergency change procedures should be integrated rather than bypassed. Make sure to cover version control, continuous integration, automated testing, infrastructure as code, deployment strategies, security scanning, approvals, observability, rollback, separation of duties, and balancing delivery speed with operational risk. Question 20. Describe how you would prioritize competing technical issues for multiple enterprise clients. I would rank issues by customer and business impact, urgency, security risk, affected scope, contractual service level, and available workaround. A widespread outage or active security threat takes precedence over a low-impact request, even if the latter arrived first. I would acknowledge every stakeholder, communicate realistic updates, assign owners, and escalate when authority or expertise is insufficient. A shared queue and clear severity definitions improve fairness. After resolution, I would review priorities, response times, and recurring demand to improve planning. In your answer, cover business impact, urgency, affected users, contractual service levels, security and safety risk, dependencies, available workarounds, transparent communication, escalation, ownership, and documenting prioritization decisions. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.